Tonight's lesson looks at the Big Bang and the formation of our solar system. We're going to start with how the universe formed and then work our way to how our solar system, right, all of the objects around our sun formed. So we're going to start with the Big Bang, which is the scientific explanation for how the universe got here. All right, this is what we have our evidence to support. And what that shows us is that about 13.7 billion years ago, all matter in the universe was condensed to a single point. This is so really hard to comprehend that all the galaxies, all hundreds of billions of galaxies, everything that we can see, everything that exists today was something smaller than the period on your screen right there. So it's incredibly dense. And for reasons that we don't really know, it exploded outwards. Right? And all of this material exploded outwards, and it's still expanding today. So for some reason it exploded outwards and continues to expand. So we don't know what happened before this 13.7 billion years ago. We don't know if the universe existed before then. We don't know what it would have looked like, but we know that 13.7 billion years ago the universe exploded, all of the matter exploded outwards. And about 400 million years after that, we started to get stars, and everything then began to kind of clump together in galaxies and keep moving. So how do we know this, right? What evidence do we have? As scientists, we're always looking for evidence, and it turns out we have some pretty good evidence for this. All right, so evidence is that all galaxies are moving away from each other, right, as if they were pushed away from a particular point in an explosion. So all the galaxies are moving away from each other like they exploded away from a point, right, which is the Big Bang. We also have this background radiation is left over from the Big Bang. So when scientists point telescopes to space, if they can detect radio waves, they see this really weak radiation in the background, kind of behind all the stars. It's just kind of there, and as best we can tell, this is actually leftover radiation that formed when the Big Bang happened. So this radiation has been around for 13.7 billion years, and we're still detecting it today. Radiation is detected in all directions by radio telescopes. So a radio telescope is a telescope, but instead of seeing visible light, it sees radio waves, right? Which we know is just a different form of light with a different wavelength, right? So we have this really solid evidence that shows us that the Big Bang happened, right? This is a real event. It took place 13.7 billion years ago, and it explains why our universe is here. So after this Big Bang exploded outwards, now we have all this matter exploding and racing outwards through space. So how does this then form our solar system? How do we get the sun, the earth, all the other planets? All right. And now we're going to look at how that happens. So in our solar system, right, it turns out gravity is a force that pulls matter together. We know that you and I have gravity, but because we're so tiny, that gravity doesn't really make an impact on our lives because the Earth's gravity is so much stronger. But if you're just floating in space and you have a lot of time on your hands, eventually gravity will pull matter together. So after the Big Bang, right, gravity slowly pulled matter into galaxies, which were giant collections of stars. So we have these huge now collections of stars, right? Stuff is starting to come together. Gravity is pulling all this stuff together. Starts to rotate as it comes in. They kind of spiral in on each other and eventually keep rotating to form a galaxy. And within these galaxies, you have a huge clouds of gas and dust called nebulas. So they're huge clouds of gas and dust called nebulas exist. All right. So this is the formation of our solar system. So this is another nebula. This is not the one that our solar system formed from, but this is one that we can see from Earth. You can see there's just all this gas and dust in space, And from one side to the other here might be, I don't know, 10 billion kilometers. So this is a huge area, and gravity just ever so slowly just starting to pull this stuff all in together. So in our solar system, right, gravity pulled the nebula that we formed from closer and closer together. Right, this nebula doesn't exist anymore. It's now the planets and the sun. So gravity pulled our nebula closer together, and then eventually the gas at the middle became so dense that nuclear fusion starts. And that forms the sun. Right? We know that the sun has nuclear fusion at the center of it. That's the reaction that gives it its energy. So as this cloud of gas and dust here gets compressed together by gravity, as things get bigger, they have more gravity, they pull in more stuff, so they have even more gravity, so they pull in even more stuff, and eventually it's so dense that nuclear fusion begins, and now we have a sun at the center of our solar system. But we still, as you can see in these pictures, we still have lots of junk orbiting around the sun, right? And we have all this junk moving in a circle around the sun. And this remaining material continues to orbit the new sun, and gravity keeps pulling it together, right? And so this is just a painting of what an artist thinks the early solar system might have looked like. So as these little pieces of junk orbit the sun, their gravity starts to pull them together, and they start to combine. So the material orbiting the sun is pulled together by gravity again and clumps to create planets. Right? The heavier materials tended to get pulled closer to the sun, right? Which is why the inner planets are made up mostly of rock, and whereas the lighter materials were farther away from the sun, the hydrogen and helium that make up the outer planets. And all of this took place about 4.6 billion years ago. All right, so you can see there's quite a bit of time between the Big Bang and the creation of our solar system. So almost 10 billion years went by between the Big Bang and our solar system forming. All right, so this is some pretty heavy stuff. We're going to talk about it in class tomorrow. And please write a summary tonight. Please fill in the questionnaire, and I will see you in class tomorrow to discuss it.